Welcome back to CS 143, Intro to Data Structures. This is the fourth lecture in Chapter 9, Inheritance and Interfaces. Previously, we have covered Section 9.1 with the basics, 9.2, how to interact with superclass, Section 9.3 about polymorphism. This lecture is going to break with that form and actually cover the last three sections of the book all in one. Really, the bulk of this chapter, the most important things have been covered now in section 9.1 to 9.3. 9.4, it's not really less important, but it's at a higher level. So you really need to understand these first three things in order to move on. A lot of these things also become much more relevant and understandable in chapter 10, so I'm going to combine them and try to go over them a little bit quicker. Section 9.4 of the book is about really what you can't do with inheritance. They give a good example here of suppose you want to create a 3D point, and you might think that what you want to do is you extend the point class. You recall a point has an x and a y, so we could create a subclass called a point 3D, and we would just add a z parameter and set that z parameter to something, and of course you're going to have a bunch of other routines to handle the third dimension. But the problem is that you can then create a point object and assign it a new point 3D. And as you might imagine, a 3D point has all this other information about it, and you can't really treat it the same way as a 2D point for a lot of different reasons. But I mean, just even the concept, it's clearly not the same thing as, say, subclassing an employee to a secretary. All secretaries have the same things common with employees, and you can treat a secretary like an employee. You can't treat a 3D point like a 2D point. And as a little tribute to one of my former teachers at MIT, I want to point out that the book mentions Barbara Liskov, who taught at MIT and was a recipient of the Turing Award, which is the equivalent of the Nobel Prize. And she has a principle called substitutability. It's quite a mouthful. And it's actually not a term I was familiar with. I looked it up, and it turns out she actually introduced this term at the same time I was taking the class from her. So that's why we never learned it. But what it basically points out is that classes that are subclasses should be able to do this here. They should be able to be used as their parent class, and this case doesn't work. So this is an example of what you can't do with inheritance in Java. Another thing the book points out is that oftentimes you'll have classes that seem to be related, but they are not subclasses of each other. So for example, in chapter 8, I brought up the example of a card game like blackjack. So you'd imagine you'd probably have some sort of card object that would have a suit and a value. And then there's a deck object that would have an array of those cards, and it would probably have methods on how to sort it and how to deal them. But one is not a subclass of the other. You can't treat them like the same. And then similarly, you probably have a blackjack object, and it clearly would have a deck of cards, and it would have rules about blackjack, but again, there's no relationship saying that you can treat a deck like blackjack or blackjack like a deck. It just doesn't make sense. So they introduced the concept of has a. So a blackjack has a deck object, a deck has a card object, but they do not inherit from one another. So what Java does have is interfaces. This is a very powerful concept, one which I can pretty much guarantee that you are going to use, certainly in this class, but even outside this class. If you ever want to do something interesting with Java, you're probably going to be using interfaces. So this is a very important concept. So interfaces let us have multiple things that have the same type of function, but they don't have to be subclasses of each other. I'm going to jump actually ahead to take a look at, again, let's go to an actual example of an interface. So an interface, for example, here, you've got a shape. Now, you declare what kind of interfaces, what kind of methods this interface is going to have. So in this case, there's an area, and get perimeter. So you can implement something like a circle that implements this interface shape. And so you can figure out the area is pi r squared, you can get the perimeter is pi d, and you can implement a rectangle. And the area is length times width, and the perimeter is twice the length and twice the width. And so they're completely different implementations, but they provide the same interface. Some terms here are that these methods, because they're not actually implemented here, are called abstract methods. And basically, shape, an interface such as shape, just promises that whoever implements the interface has to implement these two methods, or however many methods an interface might have. You should recall that classes are like templates. When you declare a class in a Java file, you don't actually get an object. So if you implement a rectangle, for example, just putting the rectangle class there doesn't actually give you a rectangle object. You have to say rectangle R equals new rectangle. Similarly, interfaces are a template for creating classes. So when you create an interface, this right here is sorry, this is not the definition of an interface, but when you declare an interface, it doesn't actually create a class. This right here is a class, and it implements shape by saying implements whatever the name of the interface is. Now, this class definition is not complete because you may remember just a second ago I told you that anything that implements an interface has to guarantee that it actually implements the interface's methods, which were getArea and getPerimeter. So the rectangle class would have to provide implementations of getArea and perimeter as well. And this then, once you have several different classes that implement the shape interface, you can then achieve polymorphism. And again, that means that one single line of code can actually execute different code depending on what the object is. So you can say object, if O is an object name, you could just call it O.getArea, okay? And we don't know what that line of code is actually going to execute until that object O is assigned to be a rectangle or a circle or a triangle or whatever other shape implements the shape interface. Now, we will make this more concrete with some code, but before I go there, I want to just mention that there is an even more complex thing called an abstract class. So an abstract class is halfway between a regular class, which has all of its methods implemented, and an interface, which has none of its interfaces implemented. So an abstract class, really I think the best example that the book gave was pretty straightforward, is like an employee. So an employee has a name and an ID, but when you hire someone into the company, you don't hire just an employee, you hire a factory worker, you hire a secretary, you hire a janitor. So you would probably actually call the employee class an abstract class. And the main thing is that when it's an abstract class, nobody can create an instance of an abstract class. And it's really just an indicator to people who use your classes that you don't want anybody to create this class, okay? It's just a high-level class that people can then subclass in order to take advantage of code sharing. So let's go take a look at some code examples and try to make this a little more concrete. So you may remember from the previous videos of chapter 9.1 through 9.3, we've been working with this employee example that's similar to what they have in the book. And let's go take a look at the definition of the employee class here. So it's got the name, the hours, and all of the methods to access it and give it a toString, etc. But let's suppose again that we don't really want to ever create an employee. We want to force people to actually create a subclass of employee. So all we have to do is change this definition to be abstract. So we'll do public abstract class. Now, as soon as I do that, the compiler is going to start enforcing that rule that you cannot create an abstract class. So already we get some errors up. Cannot instantiate the type employee. Same thing here, and here cannot instantiate the type employee. So instead, let's quickly go and implement another subclass of employee. So let's do a class. So let's say that salesperson is a type of employee. Extends employee, and a salesperson has a let's say it's a quota. Let's give an int, private int quota. And let me just quickly put in a couple of things here so that we can run this example. All right, so I've gone ahead and created a get quota, a quota, a set quota, a toString. So now we can actually use this class. So here, instead of employee, I'm now going to do a salesperson. And of course, I got to change that here. Oh, actually, we don't have to change these. We can actually leave these employee. You can assign to the parent abstract class. You just can't actually create it. And let's go down here. We'll create that to be a salesperson. The salesperson, we've already got a secretary. Okay, so now I think it's actually pretty happy. So we can run this. And yes, it's all working. Okay, so now we've created an abstract employee class. You can no longer create an actual employee. You have to create either one of the subclasses, which in this case is a secretary or a salesperson. Okay, so I've shown you what abstract classes do and why you would use it. Again, why you would use it is because you don't want people to create an employee, in this case, of that type, that abstract type. This will prevent them from doing that, and it'll just allow them to use your code. Now I want to switch to showing you some examples of interface code. To be honest, it will be very rare that you will create a new type of interface. Instead, really what you're going to be doing is you're going to implement interfaces that people have already designed. I think the most fabulous one is one called comparable. So here is a student class. If you forget about this part about implements and just look at the student class, you can see there's some sort of an ID, a name, and an age, and here's a simple constructor. But what if you actually want to be able to sort a list of students? How are you going to sort that? Is it going to sort it on name? Is it going to sort it on integer? Is it going to sort it on the age? Well, that's what compare to is for. So there's an interface called comparable. So if you just say whatever your class is, you add the implements comparable we'll talk more about this later, but if you implement the comparable interface, then all you have to do is implement for this particular interface one method called compare to. Okay, and this compare to is just going to return 0, 1, or -1 depending on how this particular this dot object compares to this passed in object here. So you implement that, and now you can actually sort an array of students. That's a really, really powerful thing. So you're going to be using Java classes all the time that create great things like sorting and searching, and all you have to do is implement certain interfaces in order to be able to take advantage of that. So again, interfaces, you probably will not be creating interfaces on your own. You probably will be implementing them. Okay, so you just add the implements and then the name of the interface, and then you have to implement whatever methods are in that interface. So that's an example of why you would use interfaces, how you would use interfaces, and a good example that can help you remember what's going on. So let's do a quick review of this chapter now. So section 9.1, that's the simple, how do you inherit from a class? How do you extend a class? Section 9.2 is how do you interact with a superclass? How do you use super? How do you use the super's constructor? Section 9.3, polymorphism. Again, one line of code needs to do different things depending on what that object is. And then we just covered 9.4, which is basically what you can't do with Java single inheritance. And then what you can do is you can create an interface. I'm not going to go over the financial class hierarchy. Instead, what we did is we took a look at the code that I created for the employee class. And let's just review the code that we talked about. So we've got an employee class here, and then we created a subclass by saying class secretary extends employee. And we can access the superclass by, for example, calling super, which is the superclass's constructor, or we can call super dot and then any of the superclass functions here. That's how you access your superclass. For polymorphism, we showed you an example here where you have an employee which, because of subclassing, can be any of several different subclasses, and you can call a method on that employee, and then you don't know it, looking at this line of code, what type of code is going to be executed. And then we also showed you interfaces, and interfaces are another way where you can implement several different classes can have the same function implemented on them, and then you don't know exactly which code is going to be executed. And then in this current video, I just showed you how to use abstract classes. So we turned the employee class into an abstract class, and again, you want to do that sometimes to prevent people from actually using this class, which isn't intended to be a real object. You just want people to subclass it. And then we also talked about interfaces. I didn't use this code. I actually used the card code to talk about how you would probably want to implement comparable, the interface, on probably on the card or the deck, so that you can sort, or you're actually probably on the card, so you can sort the cards. Okay, if you implement the comparable interface, you then can take advantage of the sorting algorithms. You don't have to write your own sorting algorithm. So that's a huge advantage. Or, for example, you could actually implement comparable on an employee. So then you could decide, you can sort the employees by first name, last name, by the hours that they work, whatever field that you want. But you can take advantage of sorting just by implementing comparable. So that is the end of Chapter 9. So we've had 4 videos. If you liked the video, please like and subscribe, and you can get access to the whole series of lectures. Thank you very much.